Hello scholars, welcome. Mr. Hinkle here. We're talking about sediments, and there's a very special type of sediment that we like to call dirt, aka soil. Wildly important, possibly Earth's greatest natural resource depending on who you talk to, often overlooked, definitely misunderstood, but steeped in scientific processes for the formation, how we classify it, the development of the various layers, soil profiles, and how it erodes on the landscape, which can cause a whole slew of varying issues. Let's talk about it. So, soil is created from organic material, rainwater, and organisms, and the basis of soil is sediment. Remember, sediment is loose fragments or broken pieces of rock at Earth's surface. And when soil mixes, when sediments mix with air, water, minerals, organic material, you have the perfect combination. The ingredients are there to develop a very unique substance that is home to diverse ecosystems that we can't even see, that we don't even know are there, but are present all over the world. Soil develops slowly over time, and this is what we're here to talk about it. So, necessary key component of soil is organic material. There's trees. The leaves on the trees fall and they accumulate on the surface. The cycle of life happens, different plant materials grow, they shed their leaves, they die. That material forms a thick layer of plant debris called humus. The humus is crucial for soil development. Okay, let's start to do this. So we've got soil. Hello, soil. And keywords on the board. Humus. Plant debris. Okay, three things are happening. Chemical and physical weathering produces loose debris and ions in solution. Number one, sediment forms. Number two, downward percolating water redistributes ions. When it rains, the water infiltrates into the subsurface, and the movement of that water can dissolve ions and redistribute those ions in the subsurface. Number three, below the surface, there's an interaction with organic material. So what do we got? We have sediment, we have rainwater, and we have organic material, our big three components for soil. Sediment, what did we say? Rainwater and organic material. Excellent. Where's my clicker? Anybody know? Thank you. So, here's the surface. And humus is going to accumulate on the top. Let's just say that, humus. Great. Well, it's going to rain. It's going to rain. It's raining. And that rainwater will land on the surface and then infiltrate and percolate down. Water is the medium for chemical reactions. It is the agent of physical and chemical weathering. And as the water percolates down, there is a distinct arrangement of various layers, these layers forming what is known as the soil profile into individual soil horizons. And it's a systematic, structured, repeatable sequence. of horizons, O-A, E, B, C, and R. Let's talk about them. So the organic layer is this top layer. It is where you have the most amount of plant debris or humus. Underneath of that, you have, so we're going to say the O is here. Underneath of that is going to be the A, correct me if I'm wrong, A, and our A layer is where we have topsoil. So you scoop your hands into that very fertile, very nutrient-rich layer of soil. You're looking at the A horizon. The E horizon is a transitionary layer. The transition is going to be between different zones. The zone of leaching, where you have material that's making its way down, into the zone of accumulation, where we have the subsoil. Excuse me. Okay, so here we go. Let's do some different colors. Topsoil, transition layer, subsoil. Next layer is C. Yes, okay, the C. This is going to be the parent rock. Wait, yep, the parent rock. So in the parent rock, we're getting close to the solid rock. It is not interacting with any organic material, but it is subject to weathering processes. And then below the parent rock, we're going to have the R, which is going, excuse me, which is going to be the bedrock. Another word for this are unweathered parent rock. So we can see, and I'll show you here, the various layers of our soil profile consisting of variable or various horizons. The organic layer, rich in humus. The A layer, topsoil. The E is our transitionary. The B is our subsoil. C, we have weathered bedrock. And then R is the bedrock that is untouched. Now, it might be a reservoir of holding groundwater, i.e. an aquifer, but it is not breaking down into smaller pieces, which is the definition of weathering. Many factors are important for the development of soil. One of the big ones, maybe the biggest one, is going to be how much water is there. So climate. Soils need wet conditions. It's one of the 3 key ingredients. So dry areas don't form as much soil or any soil because they don't have the required amount of rainwater. Climate, wildly important. Substrate composition, right? So we'll say water. Substrate, that's saying what is the mineralogy of the bedrock? Can the bedrock break down into smaller pieces to transform into soil? Slope steepness, right? And so soils need relatively flat slopes to accumulate. If it's on an angle, well then the downward force of gravity is not going to allow those soils to actually develop. Wetness, not only is it going to be how much rainwater, but how often does that water persist for soils to form? Time. Soil needs a long time to develop. And then the local ecosystem. This is looking at the biodiversity that is inside of the soil, because it's not only the organic material, but it's also the microbiology that's occurring within the whole soil profile. Great. Classification. So what kind of soil is that? Well, it depends. It depends on who's creating this classification system. In the USA, we have the U.S. Comprehensive Soil Classification System that give us 12 orders of soil taxonomy. This is going to be based on the physical characteristics and the environment of soil forming factors. So put all these together, and then how does it look? What is the color? What is the primary grain size? All of those. We can take this soil classification system, apply it globally to understand trends. And some main trends that we see that jump out is that soils are common across latitudes. There's a latitudinal gradient that shows up in a lot of things. Shows up in atmospheric circulation, oceanic circulation, ocean salinity, arid versus semi-arid and tropical climates, and we see it here in soil classification. So if where you are, north or south latitude, is going to constrain what types of climates there are, and climate is the #1 factor for soil formation, then it makes sense that soil profiles are controlled by what region they are located within based on latitude. So soil formation takes time and all these factors, and soil doesn't just form, it also erodes. The removal of soil by running water and or wind, natural process. Erosion, natural process. But when human activities are increasing the rates of erosion where erosional rates exceed formation rates, this can be a huge issue when it comes to agriculture and to supporting the biodiversity and to habitat removal. So this becomes more of an environmental science topic where issues can arise because of human activities causing for increased erosion of the valuable nutrient-rich topsoil. We saw this happen in the 1930s. This is our big case study. This is just the biggest example of it. 8 years of drought started to occur. Poor farming practices, newly developed, expanding across the landscape. And when you had drought with poor farming techniques and big winds, basically the winds came and stripped or denuded the land of their topsoil, creating significant impacts to the residents who were living in the Midwest at this time. Really, it was Texas, the Oklahoma Panhandle, that region over in there. And this is a warning for us, or it's something to remember. If we don't take care of our soil, then it might just blow away, because our soil is possibly one of the greatest natural resources that we've ever come to have on our earth. It's really important. Civilizations have risen and fell based on how they treated their soil and the ability to preserve this resource in order to utilize it to feed the growing population that we have in our society. So, soil, a special kind of sediment, one that is very valuable and important for you and I. Thank you so much. I'll see you again.